Go.
Hi, I'm Robbie Duff, and I'm here representing the Collinsville High School in the SIU Math Week Challenge problem. So here is our answer and proof. In any set of numbers, the sum of the differences between, in any sum of consecutive numbers, the sum of the differences between the numbers will equal the final number. So to find a cube, you can add up all the sums of the differences of the cubes leading up to that cube. So the sum of n cubed minus n minus 1 cubed equals n cubed minus n cubed minus 3n squared plus 3n minus 1, which altogether equals 3n squared minus 3n plus 1. Am I supposed to be narrating this? Okay. So if that follows, then the summation for a cube should be from k equals 1 to n, 3k squared minus 3k plus 1, that should equal n cubed. So we're going to do proof by induction. So when you put 1 in for n, it'll be 1 squared minus 3 times 1 plus 1 equals 1. 1 cubed does equal 1, so that's true. For induction, we assume that for n it's true, so for n plus 1 cubed should equal the summation of k equals 1 to k equals n plus 1 for 3 for that, which should equal, which does equal because of summations, the original thing with n in it plus 1 and n plus 1 inserted in for all of this. So it's that plus 3 times n plus 1 squared minus 3 times n plus 1 plus 1, which we're assuming through proof by induction that this all equals n cubed. That's n cubed plus 3 times n plus 1 squared minus 3 times n plus 1 plus 1. So put that all together, factor it all out, that equals n cubed plus 3n squared plus 3n plus 1, which does equal n plus 1. Cubed. Oh yeah, we can't pause this.
Excuse our star, he has to get a bite. He's a little hungry. What you eating there, Robbie? Is that Breadco? You know, in Carbondale it's called Panera. It's not St. Louis Bread Company.
That's dumb.
I know.
I didn't rehearse this part. So we're trying to prove the same thing. We're doing the same premise. So n to the power of the fifth minus n minus 1 to the power of the fifth equals all that, equals that. So we're assuming that n to the power to the fifth equals k equals n equals 5 times k to the fourth minus 10 k to the third plus 10 k squared minus 5k plus 1. So for k equal 1, that's 1 to the fifth equals 1 to 1. 5 times 1 to the fourth plus minus 10 1 to the third plus 10 1 squared minus 5 times 1 plus 1, which does equal 1. 1 to the fifth equals 1. Good. So we're assuming for n it equals it. So for n plus 1 to the fifth equals k n plus 1, same thing, which equals, we're using this to refer to the original thing, not my idea. So that equals all of this plus 5 times n plus 1 to the fourth minus 10 times n plus 1 to the third plus 10 n plus 1 squared minus 5 n plus 1 plus 1. So that equals n to the fifth. So that equals all of that, which factors out to, erase some of it. Yeah, that factors out to n to the fifth plus 5 n to the fourth plus 20 n to the third plus 30 n to the n squared plus 20 n plus 5, which does equal n plus 1 to the fifth. Really? This isn't bad enough already, Carbondale people.
Hola.
I'm autistic, okay? Let's be honest.